Students, let us continue the 12th question. A coin is tossed thrice. Find the probability of getting exactly 2 heads or at least one tail of 2 consecutive heads. Okay, how many coins? Only one coin thrice. Okay, 3 times one coin is tossed. The same way, 3 coins tossed one time. Both are same sample space. Okay, so anyway, you consider 3 coin or 1 coin thrice. Now we have to find the probability of getting exactly 2 heads or at least one tail. So exactly 2 heads you consider as an event, then at least one tail you consider as an event. You need to find the probability of the union of these two sets. That's only given R. Okay, so we can write the sample space first. Given a coin is tossed thrice. Therefore, S is equal to set of all head, 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 tail. Next, head, tail, head, head, tail, tail. Then tail, the same, only first change, the remaining all same. Head, tail, head, head, tail, head, tail, 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 head, tail, tail, tail. Okay, so what is the n of S value? It is 8. Are you clear? Now we can consider the 2 events. First one is for 2 heads, second one for at least one tail. Let A be an event of getting exactly 2 heads. Therefore, A is equal to, so what are the elements in A? Exactly 2 heads. Okay, don't choose 3 heads. Here 2 heads. This is 2 heads. Only 1 head you don't choose. 2 heads. Only this much. Okay. Only 2, exactly 2 heads means no more head or tail. Understood? So H, H, T, H, T, H. Next T, H, H. Okay. So what is n of A? Equal to 3. Therefore, P of A equal to n of A divided by n of S, that is 3 divided by 8. Okay. Next, we can choose the next event. Let B be an event of at least one tail. Therefore, B is equal to event of getting at least one tail. So, what are the elements in A? At least one means minimum one tail. Okay, minimum one tail. So, you can choose 2 tails and 3 tails also. Okay, so except this first element H, 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 the remaining all you can choose. That is the meaning. So, H, H, T, H, T, H, H, T, T. Next T, H, H, T, H, T, 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 H, T, T, T. Minimum one tail, no? One tail is there in everyone. Okay, so this all elements you can choose. Therefore, n of B is equal to 1, 2, 3, 4, 5, 6, 7. So we can find out P of B using the formula. Okay, next one. Here in the question I written on mistake, this is R. Okay, so you have to choose the third event also. 2 consecutive heads. Okay, so A, first head, exactly 2 head. B, at least one tail. Then C, exactly 2 heads. So you have to find the probability of A union B union C. Are you clear? So next we are going to choose, let us say, be an event of exactly, C be an event of getting 2 consecutive heads. So from the sample space, where I have the two consecutive heads, first one, second one, then this fifth one. Okay, only these three elements have consecutive heads. So these three we will select for the C set. Are you clear? Okay, we can continue to find out the P of B now. Therefore, P of B is equal to N of B divided by N of S. N of B is 7 divided by 8. Okay, next third even, let C be an event of getting two consecutive heads. Therefore, what are the elements in C? First element H, H, H. Second element H, H, T. Then fifth element T, H, H. Okay. So what is N of C? How many elements are there? 3 elements. We can find out the P of C value. It is N of C divided by N of S. That is equal to 3 by 8. Okay. Then since we have 3 elements, we have to find out have any common elements. Okay, then only we can apply which we can find out which rule, which theorem we need to apply. Okay, 3 events are there. First we can find out A intersection we have any elements. Then if you have any elements, you can find out probability for that. Next B intersection C, next A intersection C. Okay. Okay, now you see A intersection B have any common elements in A and B. A set H, H, T, H, T, H, T, H, H. B set is this whole 7 elements. So have some elements common. We can find out that common elements. Now you see H, H, T, H, H, T, that is common. Okay, then H, T, H, H, T, H is there. T, H, H, here T, H, H. Okay, so what are the elements in A? All the 3 elements are in B also. So we can write these 3 elements in the intersection of A and B. Okay, so N of A intersection B equal to 3. P of A intersection B is also 3 by 8. You will get it again. Next we need to find the intersection of B and C. B and C, this H, H, H is not there in the B. Okay, H, H, H is not there in the B. Remaining 2 elements are in the B set. Since in the B set you have 7 elements, no, except this H, H, the remaining 7 elements are there. So these 2 elements we can write in the B intersection C. Okay, next A intersection C. In the A intersection C, H, H, T. In the C, we accept this T, T, T. We have all this. No. In the A intersection C, only T, H, H is common. So only one element. Okay. Common and write T, H. This element also there in the C set. So H, H, T, T, H, H. 2 elements are in A intersection C. Okay. So we can find out A intersections for these two sets. Then at last we need to find the intersection of all the 3 sets. Okay, we can continue now. A intersection B is equal to, what are the elements are there? You see here A set and B set. So H, H, T, H, H, T. Then H, T, H, then T, H, H, it is there, T, H, H, this T, H, H. Okay, therefore N of A intersection B is equal to 3 and P of A intersection B is equal to 3 by 8. Are you clear? Next we can find out B intersection C. What are the elements are common in B and C? HHT first element of this B set. Next HH is this triple H is not there, then THH, this element THH. Okay, so how many elements are there? N of B intersection C, only 2 elements, and P of A intersection C is equal to, B intersection C is equal to 2 by 8. Don't reduce this. Okay, since we need the calculation, so don't reduce now. Next we can find out A intersection C. What are the elements are there? A, H, H, T, that is in the C set. Then T, H, H, that is also in the C set. Okay. So 2 elements. H, H, T, T, H, H. So N of A intersection C is equal to 2 and P of A intersection C is also equal to 2 by 8. Okay. Now we can find out this all together. A intersection B intersection C is equal to, okay, altogether how many elements you see? A intersection B intersection C, what are the elements are common? HHT, it is there in the HHT, 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 okay, in all the 3 sets. Then this THH, THH, THH. Okay, that is also in all the sets. Then HH, triple H is not in B. Okay, and not in A also. Only these 2 elements. So we can write set of all HHT, THH. Okay, therefore N of A intersection B intersection C is equal to 2 and P of A intersection B intersection C is equal to 2 by 8. Okay. Now we know this addition theorem for 3 sets. P of A union B union C is equal to P of A plus P of B minus P of A P of C. P of A plus P of B plus P of C. First we add these 3 sets separately. Then subtract the intersection of 2, P of A intersection B minus P of B intersection C minus P of A intersection C plus the intersection of all the 3. Okay, intersection B intersection C. Our question is to find probability of exactly 2 heads. It is the A set. R means union, at least 1 tail. It is the B set. R union, 2 consecutive heads, 3. So A union B union C. Okay, that is equal to probability of A union B union C. Now you can apply the values. What is the probability of A value? Probability of A is equal to 3 by 8 plus probability of B is 7 by 8 plus probability of C is 3 by 8 minus probability of A intersection B is 3 by 8 minus probability of B intersection C is 2 by 8 minus probability of A intersection C is 2 by 8. Next plus probability of A intersection B intersection C is also 2 by 8. Okay. Now we can cancel which are the numbers, you cancel it before finding the LCM or addition. Plus 3 by 8 minus 3 by 8 minus 2 by 8 plus 2 by 8. Okay. So the remaining 3 by 8 plus 7 by 8 minus 2 by 8. Okay. Now it is easy to do. So 8 is the common denominator. 3 plus 7 minus 2. 3 plus 7 is 10. 10 minus 2 is 8. 8 by 8. That is equal to 1. Now the probability is equal to 1. That means it is the sure event. Okay. Answer: probability of exactly 2 heads or at least 1 tail or 2 consecutive heads. is 1. Okay.